Hello everyone, welcome to our presentation, Life's Too Short for Rugged Food Bites. Diego, Charles and I build a review-based discovery engine for restaurants. So what's the story? I arrived 2 months ago in Lisbon, as you can see, I tried almost 100 of restaurants. With many great experiences, and some others more questionable. So what we do? To dodge bad meals, usually we ask our friends, yeah, this is a good place, this is not, etc. But what happens when we don't know anyone in the place we're arriving? For instance, my friend Diogo is moving to Philly next month. But now, imagine, wherever you go, having a millions of food-savvy friends at your fingertips who know exactly what you need. Well, this is what we build.
And this is exactly the role of recommender systems. Today, you're interacting hundreds of times per day with a recommender system without even knowing what it is. And in recommender system basically learns with the interaction of millions of users to then give personalized recommendation for each users. They basically influence what we order, what we listen to, what we read, and what we binge watched. But unfortunately, often, the recommender system are focusing on pre-consumption signals. What that means? They are focusing on what the user clicks and order. But what happens if what you order, what you've read, you didn't really like it? The recommender system may keep recommending to you the same similar content. And that's why we focused on reviews. Reviews are actually a really strong signal of like and dislike, because no one will waste the time and energy to leave a review if it had an okay experience. So that's why we focused on review. How do we cook our recommendation? The first step was to actually interpret the reviews, to understand what kind of experience the user had with this restaurant. And for that, we did a review sentiment analysis, and we'll deep dive in that in a second. Then we built an industry standard architecture, kind of like multi-stage ranking recommender system, with the first step, which is candidate generation. The purpose of candidate generation is, out of millions of options, let's isolate the most relevant for this user. And for that, we need to use a lightweight, fast, and approximate model to extract the candidates. What we did, and Guillaume will explain that in a bit, we basically encoded every restaurant and users with embeddings, with vectors. Think of it of a fancy way to just represent a restaurant or a user with the numbers. And the goal of that is that every number will make that a restaurant and a user that are similar are really close together. With that, we extracted all the candidates. And with this subset of candidates, we then pass that through a ranking system. Now that we have a smaller number of candidates, we can use a more complex model, compute a couple of online features, which are basically representing the interaction of the user with each of the restaurants, and then classify all these restaurants to give a probability of the user liking or disliking these restaurants. So now let's deep dive into how we did it. First, unpacking the sentiment of every reviews. We had more than 600,000 reviews. That's way too much to read and classify by hands. So we had the help of Distilbert. Distilbert is basically a transformer architecture, pre-trained with large corpus of data from the internet from everywhere. Transformer, think of it as ChatGPT, the architecture that's behind all all the ChatGPT, Gemini, Llama that you're using every day. And we read all the reviews that sometimes they are really self-explanatory and others are a bit more complex to interpret. And we basically classify them as, yeah, the user had a blast, or no, the experience wasn't that good.
Now let's dig into the similarity search. First, what we did. We represent each restaurant by all the comments he got, and then we use a deep learning language processing tool called Word2Vec to transform each word into a vector, and then each restaurant into a combined vector. Then, we position each restaurant in the vectorial space in order to visualize the similarity between the restaurants. Then, we do the same with the users. The users is defined by all the review he puts, all the restaurant he liked, and using the same method, we define vectors for the users, and therefore we are able to position the user in the vectorial space in order to find the similarity with the restaurant. Well, then it's what we do. We use the cosine similarity to define the restaurant that the user is closer in the vectorial space and therefore is the most likely to enjoy. And we define a list of restaurants, and this is like what we proceed.
So then with these candidates, as I already said, we take all these candidates, like this restaurant that the user is most likely to like, and we process them with a more complex model. So first, we had to define a couple of features. And now that we had like less restaurants, around 30, 50, we computed a couple of online features, such as like the similarity between the category of the restaurant and the category that the user liked before. More features that Diogo will then explain to us. We process them through a pipeline. What does that mean? That means that we take the feature that might be from 1 to 5, from minus 2000 to infinite, and we had to like scale them to be interpretable more easily by a machine learning model. For the model, we use a tree-based algorithm, XGBoost in particular, a classifier to then say, hey, this restaurant, given this feature, I think the user will have a really great experience by a probability of X. And with all this probability, then what we have, we needed to calibrate them to make sure that they fit real life, because the model gives us some probabilities, and we need to just adjust them to really reflect the experience that the user will have.
So when it comes to training the model, we've trained the model on categories of the restaurants and categories of the users. We have also weighted the categories of the users by the reviews each user has. And then we built some engineered features, for example, difference in experience, difference in expectation, and user pickiness to define a user. Then we trained the model on all of these and also on attributes of the restaurant, for example, wheelchair accessibility. We trained the model, and the model shows us predictions, and then to try to see what the model actually looks for, we graphed some of the categories, some of the features that the model was fed to see how much of it increasing or decreasing influences the model liking the restaurant or not liking the restaurant for the user. We end up with an app. I will open it. Oh. Here, Phillybytes. So in here, we can choose a username. We've preset some user IDs with some user categories that the users, for the restaurant users have been to, and if they liked it or not. And when we input one of the users, for example, Rui, we press the let's go button. And after some calculation, it will map the restaurants, the top 10 restaurants most similar to the user's preference. It will also show the probability of each restaurant in the right side. And it will also mark, when the markings of the map are interactive, so you can actually pop them up and see the user, the restaurant location and stuff like that. For example, in here, I can see the material. And in here in the right side, we can actually see the probability of the user liking the restaurant calculated by the model, which in this case is 89% for the first, for the first place, 89%. Despite all this, we still don't have like human feedback, so we don't actually know why the machine recommends this, and so we decide to ask a local from Philly. So after a bit, the local will show up, and who better to ask than the French Prince of Bel-Air? So we get the user data, we get each individual restaurant's data, and we feed that to a large language model to output a review. And the review is tailor-made, personalized to the user, to the restaurant, and spoken by the Fresh Prince of Bel-Air, Will Smith. So we've got here the relationship between that in principle the user should have in that restaurant. And that is essentially the demo. Yeah, here. So, what? You press? No. It's stuck. Não mexe? Não mexe na app? Ah, é. Oh, never mind. Yeah, I'm done. Sorry. Here. Yeah, so essentially with this, hopefully, I will not have any May experiences anymore in Philly. I'll just have slam dunk. Thank you.